So I have been quite busy today. I've got the generator pretty much complete. Still a little bit to do, but the basic setup's there. But what I wanted to talk about today was the grid tie inverter. I've decided what the best thing to do now is have it permanently connected to the battery on the DC side, so its control logic is always running. So now the only thing that I will be controlling is the output. See, I've put a relay on there. That's a 24 volt coil relay. And what happens is, on my phone I can select an option just to switch the output side on or off. So I could switch that on, but to prevent the battery from being drained down too much, it's also going through this solar charge controller. So this will be supplying the 24 volt signal for the relay. So it's currently off just now. So that will activate, and if that relay there, this one, is activated as well, it will allow the AC side to come on and allow the power to be fed back, so I can, so it can help me charge the car. So if I press this button, that comes on, but that'll normally be on automatic anyway, and then the AC side comes to life, then it just does its thing and then starts outputting power. I've decided that's the best thing to do because when this inverter's not running, on the DC side it's drawn too little power to actually register on this watt meter, and this one is actually quite sensitive. It can register very small amounts of power. I think the smallest it can read is 10 milliamps, and this thing doesn't even take 10 milliamps. Might be wrong, this might be a bit inaccurate, but if it's not showing up on the watt meter, then really it's not worth bothering about. And this is just an old solar charge controller, but it is quite inaccurate. But I have accounted for that based on the settings that I've put in. It should just be getting ready to switch off just now. It's currently outputting 320 watts. Just want to actually see what voltage it's actually going to switch off at. Yeah, about 24.9, so that's okay. And then I'll have to wait until the voltage, can't remember exactly, gets up to about over 26 before it allows the inverter to come on, and that means that I can get rid of excess power. So this is my new system, and it seems to be working quite well apart from the mess, but it is still quite safe because everything is fused. That solar charge controller is on its own fuse, so say one of the relays totally mucks up and shorts out or whatever, then, well, there's a 3 amp fuse in there, so there's not enough amps there to cause too much trouble. And all my lights and everything are on a 4 amp fuse. That's the lights, the IP camera, the Raspberry Pi, everything, so the slightest fault there, it's just going to blow. So not much to worry about. This fuse here, that is just for the big 24 volt relay, which I'm not using for anything anymore. I might use it for something, but it's currently not being used, and its coil has got a fuse on it as well, so everything that can be fused is fused. And as you can see with that going off again, it just shows the standard fault light there. The capacitor there isn't too necessary, but I just thought I'd put it in. So I think that's the best option. It just means that the control logic is always on, and the output side, well, it's not like there's going to be a MOSFET like maybe left on or whatever. I think that's quite unlikely, but or the control logic starting up erratically and then causing the MOSFET to go on and then short across the mains. So it's better just to have the DC side on all the time, I think. One other thing I'd like to add here is that I think they've put too much fuses in it. They had two 30 amp ones, and the inverter is only rated to draw 30 amps, so that is 60 amps in total. So I'm going to put two 20 amp fuses in it. I think that's a bit better.